In this video, we are going to talk about units of measurement. We have a lot of different measurements. What are those? In this video, we are going to talk about units of measurement. We have a lot of physical quantities that we obtain through measurement. We have mass, length, time, temperature, luminous intensity, current, and the amount of substance. Here we have the SI unit of that substance and the symbol for that quantity. In science, we use something called the metric system. And the reason we use the metric system is because the majority of the world uses the metric system, so it makes it very useful for communication. Even if you don't speak the same language, your units will generally be the same. There are only three nations that have not officially adopted the metric system, and that is Burma, Liberia, and the United States. Now, the metric prefixes are added to a metric base unit, and it is done to either increase or decrease the magnitude of that number. The thing that is fantastic about the metric system, it is a base 10 system. So as soon as you know the metric system, it is going to be very easy to identify whatever unit you have. In the United States, I cannot quickly tell you how many teaspoons there are in a gallon, but I can quickly tell you how many milliliters there are in a kiloliter. I cannot quickly tell you how many inches there are in a mile, but I can quickly tell you how many centimeters there are in a kilometer. So when using the metric system, the liter, which is given the symbol capital L, is the base unit of volume. And volume is the amount of space an object occupies. The gram is the base unit for mass. And mass is just the amount of matter something has. And then finally, the meter is the base unit of length, and it is given the symbol. So here are a list of metric prefixes that you must know for this class. And it's very important that you know how to use them. So if you remember that pico is negative 12, what that means is whatever my base unit is, I have 10 to the negative 12 of my base unit in one of my picos. So if I'm dealing with meters, then one picometer is 1 times 10 to the negative 12 meters. Now, something that people can really confuse is mass and weight. So mass is the amount of matter an object contains. The big thing about mass is that it does not change based on location. You will have the same mass, the same matter wherever you are in the universe. Now, weight, on the other hand, is the force of gravity acting on an object. So, since gravity is not the same everywhere, then your weight will change based on your location. Temperature is another unit that we have, and we have three different scales that we use. We have Kelvin, Celsius, and Fahrenheit. So the Kelvin scale, which is given the symbol capital K, is known as the absolute temperature scale. And that's because it starts at absolute zero. Absolute zero is the temperature where matter stops moving. We have not reached absolute zero yet. It also means that the Kelvin scale only has positive values. The next temperature scale is the Celsius scale. And that is given the symbol degrees Celsius. Notice with Kelvin, we do not use degrees. And the Celsius scale is based on water. So 0 degrees Celsius is the freezing point of water, and 100 degrees Celsius is the boiling point of water. Now we can convert between Kelvin and Celsius using the equation. Your temperature in Kelvin is going to be equal to the temperature in degrees Celsius plus 273. Something that is important to note is Kelvin and degrees Celsius use the same size degree, but just start at different points. So if I go up, my temperature increases by 1 degree Celsius. It will also increase by 1 Kelvin. And then finally, we have the Fahrenheit scale, which is given this unit or symbol, degrees Fahrenheit. And this is the scale that is commonly used in the US. We can convert between degrees Celsius and in Fahrenheit. Do you want to calculate your temperature in Fahrenheit? It is going to be equal to 9/5 times the temperature in degrees Celsius plus 32. So this table over here gives some common temperatures of the three different scales. So water boils at 373 Kelvin, 100 degrees Celsius, and 212 degrees Fahrenheit. Room temperature is 293 Kelvin, 20 degrees Celsius, and 68 degrees Fahrenheit. Sometimes you will see it as 298, 75, or 25 and 72 respectively. And then finally, we have water freezes at 273 Kelvin, 0 degrees Celsius, and 32 degrees Fahrenheit.